All right, friends and neighbors, welcome back. It's time for masks, big idea number 4. So this will be a little bit about address space rules and to recall some things again for us. So this is really about efficiency of the address space. All right. So whenever we subnet a space, there are a bunch of addresses that cannot be used. We already know that when we have a regular class full network, one of those addresses is for the network ID, and one of those addresses is for the directed broadcast at that particular network space. So there's already 2 addresses that you can't use. That's why we always say that the usable address space in a network is actually the possible address space minus 2. Okay, so when you create subnets, no matter how many you create, every single subnet needs a subnet ID, and every single subnet needs a broadcast for that particular subnet. So these addresses correspond to the lowest possible address in the range and the highest possible address in the range. The more subnets you create, the more your efficiency goes down. Historically, this was even worse because there was a time when we didn't use the first subnet because the first address in the subnet was .0, which was the same as the class full address space, and we didn't use the top subnet either because the directed broadcast at that subnet was the same as the directed broadcast at the class full address space. Thankfully, we don't do that anymore. So now we've recovered those 2 chunks of address space, but we still have a problem. And let me illustrate the problem with an example. So let's say that you were going to create 16 subnets in a class C network. So that means that you would have a /28 address space, and the mask would look like the one you see there on the right. And so we would create 16 possible subnets, and each one of them would have a subnet ID, and each one of them would have a broadcast ID. So I put some of the address space there, but you can see the number of addresses that we can't use because of the rules we just talked about would be 32. 16 for the subnets and 16 for the broadcast. So that means that we only have 224 possible or let me say that again, we only have 224 usable addresses in the space, or an efficiency of 87.5%, which is pretty doggone lousy, but that's the cost of doing business. And that doesn't even count the addresses that you would burn for the routers. Okay, now how small can that address space get? I mean, how bad can your efficiency get? Well, if we start chopping up the subnet space even further, right? Instead of creating 16, we create 32 or 64. That means that all of those subnets would still need their subnet ID and their directed broadcast. If you create in a class C 64 possible subnets, that means that each subnet would have only 4 addresses. One would be for the subnet, one would be for the directed broadcast, one would be for a router, and then one would be for one poor, lonely host in that address space. And as an example, the 1.0 network to .3 would be the address range in the very first subnet. Okay, now you can do that with some of the address space or all of the address space, but of course if you got there, that would be half of your address space would be used for subnet IDs and broadcast. Terrible efficiency, terrible. Terrible. So we might say that this is the smallest possible address space, because if we go any smaller, right, if we did 128 subnets in a class C, then there will be no room for the router, there'll be no room for the host. So /30 might be the smallest we could go. But there is a special case where we might say, well, do we need that address for the router? Do we need that address for the host? And here is where RFC 3021 comes into play. So RFC 3021 is about using /31s for point-to-point links in a routed topology. Now, if you don't know what a point-to-point link is, I've shown you an example of one there. Routers that are connected directly to each other use point-to-point links. There's no need for hosts on those links. So to quote a little bit from the RFC, one such change to conserve address space, that is, proposed by this document, is to have the amount of address space assigned to point-to-point links. Remember that we were talking about /30s, which gives us 4 addresses, and that would be the smallest subnet that you could create. But if you don't have any hosts, you could argue that that's wasted space. So can we use /31s? So as long as they're in this particular case, then yes, you can get away with it. And the reason that you can get away with that is that because, as I've highlighted below, any packet which is transmitted by one end of the link is always received by the other. So there's nobody that you're going to direct this particular traffic to. But really what you're doing is you're ensuring that those 2 addresses are not really about the subnet or the broadcast, but they're really about the 2 ends of the connection now. Well, that's it for Big Idea 4. Remember that what we're talking about here is efficiency of the address space. Every time we create subnets, we lose efficiency in terms of addresses. And we know that we've already run out of addresses, so we want to hang on to them wherever we can. But sometimes we need lots and lots of subnets. Sometimes we need lots and lots of point-to-point links. Historically, we've done /30s there, which burns 4 addresses for every point-to-point link. RFC 3021 is a way to recover half of those addresses used on the point-to-point links by using /31s, so only 2 addresses. Well, that's it. Thanks for watching. Thanks for listening. Like and subscribe if I helped, and may your packets always reach their destinations, even if you're using /31.